tails we solve and remove duplicates from a sorted array. Given an array integer sorted non-decreasing order, remove some duplicates in place, such as each unique element appears at most once. The relative role of the element should keep the same. Since it's impossible to change the length of the array in some languages, you must result in place first part as the nums. More formally, if there is a k element after removing the duplicate, the first k elements of the nums should be final result. Okay, so we are returning k. Okay, and after k placing element, do not allocate extract space. You must modify the input in place with O1 extra memory. Okay. Yeah, so we can. There is there is always brute force solution, right? So we if we see extra third one, we just copy everything to the left until the end of the array, and then we go and copy again and again and again. But this will be quadratic time and 2 time, which is not good. If we can do better, so let's say the solution A, solution B, we could have 2 pointers, and for example, we could have a read pointer pointing 0 and write pointer pointed 0, right? And as we move forward, if we see, so if current element count, let's current element count will be 0, and as we go forward we will add 1, and if it's still 1 we will add 2, and right, if current element count is less than 3, we're moving writing pointer alone. But if it's 3, we are not adding writing pointer. We are moving reading pointer again. And then we have 2 and it's 0. And we are moving writing pointer here. And we are placing 2 here. Then we are moving pointer here. And then it's our 1, 2, right? And we're moving pointer here. And we're writing pointer is here. So idea is that we go and we return writing pointer as the result. So idea is that we constantly overwriting array. We have both reading and writing pointer, and if they're the same, we are basically reading the same element and writing the same element. But if as they become different, we are moving element into as we go. So in this case, we will gonna have time complexity ON, which is much better, and we need to and we have O1 space, right? And this is what we need. So we will go and implement this. So while so we assign read and write pointer to 0. We can say while read pointer is less than length of nums, which is length of nums. And what we're gonna do, we're gonna say at the beginning we also have current element count, which is also 0, and we also need current element. So at the beginning we assign it nums 0. We can assign count to 1, 2, and we can say if current element count less than 3, we're gonna just plus read plus 1, write plus 1, right? But we are moving read plus 1 all the time. We are not stopping it. So we'll move it outside. And what we're gonna do, we're gonna assign whatever we have on read to the right element. So also current element will be nums I, and then we assign if current element equal so let's go back to our thing, to our example. So our current element is 1. So we can say if current element count is 1 and as we move, if current element equal what we have nums r1 r, we assign current element count plus 1, else we assign current element count 0 and current element equal nums r. So we're changing current element and we return writing index, and that should be it. So we're going outside, probably outside -1. Or range. I think I can change it to make it shorter and more and better. Yeah. So, okay, let's run it through again. So we have right here, read here, right ortho 0. So we move in as we go. We reassign, which is not necessary at all, but then if current less than 3, correct, we move right. And we can say if current element, which is, we increase to 1, but this is 2, we have 2 then already, right? I think I may have an initialization problem here. So we have 1 and we current element 1 and we assign 1. Then as we go further, let's use this one. 2, 3. And then we read this one and we say less than 3, correct, right. Current element equals nums, correct, current element 1. Yeah, I believe we have to start from current element count 1 and nums 0. Okay, so we start from 1 and 1, then we move it forward. R is 0, R is 0 in this case. We have to start from 1. So right become 1. 1 equal 1, right become 3. But we have to move right even if it's 3. But then we moving right forward. We are not moving left because counter is a 3. Okay, let's print count element, count element. This. And then we also print right pointer. So right pointer shouldn't be moving, right? 0, 1, but we are not moving forward with Yeah, less than 3. So we 0, 0, 1, 1, 2, 2. Then we go 0, 1, 2, 3. Right, it's still 1, 2, which is correct. But why we stopped on L? And where we defined L? So we have 1, 1. We missed. Then we move to 4 and 5. Oh, okay. So yeah, I need to. So the problem is when I'm moving to the next one, if it's not just so. When this reset is happening, I still have to move this element. Uh, so here when we assigned from 3 to 1, I feel like I have to move this element on this assignment. Oh, because it's added twice. See, there is a one slip here. And I cannot grasp how to solve it. So here, when we move current element to 2 and we reset to 1, we still have to set it to so I'm adding it correct, but why we got error? So if up using L and R using L, then we reassign. So read is 0, write is 0. Okay. Read is 1, write is 1. Current element count is 2. Read is 1, write is 1. Current element count is 3. Read is right. Read is 2. Write is 2. Current element count is 1. Mm, I feel like I should use 1, start from 1, because first is current element count is 1. Read is 1. Read is 1. No, it's doesn't right. -1. So current element count 0, 0, 1, 0. So we added right to 1. If current element equal not equal with, okay, so we don't have to add this. Current element count 1, read 1, write 1. Current element count should be 2. feel like I have to move this guy here. Read is 1, write is 1. Read is 3, write is 2. Read is 4, write is 3. Read is 5, write is 4. And we return 4, which is... But we did not remove this one. Why? So here reassigning thing. I feel like I should put it on top. Yep. Like this. Yeah, that's it. Thank you for watching. Oh, let's check who did it faster. Yeah, it's pretty much like this. It's pretty much the same solution. I don't know why it's faster. Oh, this is cool. This is very nice. Alright, that's it for today. Thank you for watching.